Hello everyone. Today we're going to be factoring quadratics. We're actually going to do a mixed review and we're going to talk about how to factor multiple ways. We're going to talk about how to factor a difference of squares. We're going to talk about how to factor a trinomial when your a value is equal to 1. And we're going to talk about how to factor a trinomial when your a value is greater than 1 and the different methods that you would use for those. Difference of squares. So remember, in order for this to work, you have to have perfect squares and they have to be subtraction. So when we're looking at, we have a squared and b squared are perfect squares and we have subtraction in between them. So given that, the square root of a squared would give me a, and then the square root of b would give, or square root of b squared would give me b and b. The only thing that you've got to make sure of is that you have a plus and a minus when you do it. So always make sure you check for GCF first. So when I look at this first problem, I have 7x to the fourth minus 343y to the fourth. And I should be able to see that I have for 343, I can take 7 out of that. So if I GCF 7, that's going to leave me with x to the fourth minus 49y to the fourth. Now, when I'm looking at the problem, x to the fourth, that is a perfect square. Remember, anything with an even exponent is perfect. And if I have 49y to the fourth, that is also a perfect square. So I should be able to break that down even further. Now that GCF is still going to remain. I'm going to do two parentheses, one plus, one minus. So x to the fourth is, when we break that down, that is going to give me x squared. So I'm going to put x squared in the same spot x to the fourth would be. And then I'm also going to break down 49. So the square root of 49 is going to be 7 and 7. And y to the fourth, the square root of y to the fourth is going to be y squared. And there's my difference of squares. Alright, so just one more final example. There may not always be a GCF, but you should always check for one. So let's say I have 36x squared minus 1. And with 36x squared minus 1, I have 36 is a perfect squared, x squared is a perfect squared, and 1 is also a perfect squared. So I have that subtraction, so I should be able to do plus and a minus. So the square root of 36 is going to give me 6. And x squared, the square root of that is going to be x. And the square root of 1 is still going to be 1. All right. And then we have factoring with trinomials. So if I'm factoring with trinomials where a is equal to 1, then we're just going to look at, I call it an X chart, but really we're just trying to find a set of numbers that would apply to the problem. So if I have x squared minus 7x minus 18, I'm looking for two numbers that when they multiply, so when they multiply, they're going to give me negative 18, but when I add them together, they're going to give me negative 7. So we're looking for my C value, multiply to get C, add to get B. So I have multiple options. I could do 1 and 18. Well, 1 and 18 can't get me 7. I have 2 and 9. So 2 and 9 could work. We just have to figure out how to manipulate that. So we need to multiply to get negative 18, but when we add them, we get negative 7. So in order to do that, that'd have to be negative 9. So we're going to take these two numbers that I just found, and I'm going to break them into two linear binomials. So this is going to be x plus 2, because 2 is positive, x minus 9. Alright, so again, you need to make sure you still check for a GCF if there is one. So let's say that I have 2x squared minus 18x plus 16. So when I'm looking at this, I definitely see that there's a GCF of 2. So if I take 2 out, that's going to leave me with x squared minus 9x plus 8. So now this has become a problem where a is equal to 1, because the GCF, when we took that out, that made my a value 1. So we're still going to do that X chart. So I need to multiply to give me positive 8. and I need to add to get negative 9. Well, 1 and 8 would have to work, but in order to make 1 and 8 work, we'd have to make them both negative. GCF is still part of the problem, so this is going to be x minus 1 and x minus 8. So this next method that we're going to use is called slide, divide, and bottoms up. It's going to be a way to factor a trinomial when a is greater than 1. You're still going to wind up using the x chart. You're just going to do some reformatting at the beginning and at the end of this process. Now, to begin, you should always check for a GCF first, and I'm looking at this trinomial 3x squared minus 17x plus 10, and that does not have a GCF, but we are going to start by sliding the a value to the 10, and when we slide the a value to the 10, that leaves me x squared minus 17x, and that's going to be plus 30 because you multiply them together. So at this point, I need to find two numbers that multiply to give me 30, but those same two numbers will add to give me negative 17. So the two numbers that I know will work for that are going to be 2 and 15, but in order to make multiplication to be positive 30 and addition to be negative 17, we need to make it negative 2 and negative 15. So we're going to put it back together in our linear binomial. So that's going to be x minus 2, x minus 15. Now, at this point, don't think that you're done. So you have done the slide, now you need to divide. And divide basically means that I'm going to divide by the number that I slid. So I need to undo that multiplication that I did initially. And at this point, we're going to simplify. So 2 over 3 is going to stay 2 over 3. But when I look at 15 over 3, that's going to simplify. And that's going to give me minus 5. So I have x minus 2 over 3, x minus 5. And then finally, the last part is to bottoms up. Bottoms up means to mean anything in the denominator, bring it back up in front of the variable. So my final simplified form and factored form is going to be 3x minus 2, x minus 5. And if you go back to the example in that presentation, I think it's actually a PDF, but it was initially a PowerPoint. That's the exact same example that was in there. And just to give you a little bit more, so I have 9x squared minus 3x minus 12. The first thing I'm going to look for is that GCF, and I should recognize that I have a GCF of 3. So I'm going to pull that 3 out, and that's going to leave me with 3x squared minus x minus 4. And then in this parentheses, I now have a trinomial that I'm going to do that slide divide method. All right, so I'm going to slide the 3 over to the 4, and that's going to give me x squared minus x minus 12, because I'm going to multiply it together. And this 3, the 3 that was the GCF, you will continue to bring down because it's still part of the problem. So I need two numbers that I can multiply to give me negative 12, but I need to be able to add to get negative 1. So the two numbers that are going to make that work are going to be 3 and 4, but I need to make my 4 negative. So again, I'm going to bring down my GCF of 3. I'm going to put those numbers in linear binomials. So that's going to be x plus 3, x minus 4. And I've done the slide. Now I need to go back and do the divide. So I'm going to divide by the number I slid, which was 3. And simplify. So again, my GCF is still 3. I'm going to bring it down. So 3 divided by 3, that's going to turn into positive 1. And 4 over 3 is going to remain the same. And finally, bottoms up. You're going to take the bottom number and move it up in front of the variable. So this is going to be in factored form completely as 3 times x plus 1 times 3x minus 4. Hopefully this method will help you. My kids seem to like it a lot better than grouping. If you have any questions, let me know.